Hey guys, I had some stuff come up. I don't know how much longer I can work on this. I got a lot going on. Too much to put out on the internet. A little bit of trouble going on. You need to familiarize yourself with this paper. That electron right there. Top left, capacitance. Q equals C times V. Where Q is in the charging columns, it is actually the number of electrons times the elementary charge, which is the charge on electron plus proton. How many electrons, the number of electrons in one column. Well, there's your formula right there. N equals one column over the elementary charge. So I drew a little atom here to kind of so you can get familiar with how this works. The number of electrons in that molecule right there is 5 if you count the outermost shell. So each electron has an elementary charge of that formula, 1.6 times 10 to the negative exponent 19. That's your charge. Oh man. So the charge in columns, as you can see, equals N times E, which is the number of electrons times the elementary charge. If you look down here under the molecule, you will see the formula Q equals N times E. That is the elementary charge times the number of electrons. So that's your charge in columns. You know, a bolt of lightning has about anywhere from 5 to 20 columns. Okay. The column is a certain number of electrons. Electrons is the elementary charge. Anyway, I'm sharing this paper with you. 1 amp equals 1 coulomb second is a base unit of charge in a metric system. This is what I want you to do. I'm going to back this camera off. You see this paper right here? I want you to copy it. Get you a pen, get you a pencil, freeze this screen, and everything I have here, write it down. Familiarize yourself with it. This is 0-point energy. I'm not using nothing other than a coil with about 28-30 gauge copper coated wire, and there it is Biffler about 8 times. Anywhere between 5 and 10 times you will get this result. That's the positive red lead to the function generator there on top. The yellow wire is going directly between the 4 leads. Turn the light off. Let's see, turn this light off. See there? That's your free energy. This cell's been running about 10 minutes, 15. There's probably not even 2 to 6 volts coming out that red lead, causing that coil to resonate. It's about almost 1 inch tall, about 3/4 inch in diameter. And again, I am not using a high voltage coil. I'm not using a toroid. That's the only thing I'm using. That and nothing else. There's the, I'm holding that down so it doesn't fall off the table. And if you follow that on around, you will see that it goes to the leads. The black wire's the negative lead. The white's the positive. There's no tricks here. And that's my charging cord to my light. This cell has not been run before this video. It's fresh water. There has been no DC voltage connected to that fuel cell at any time this week or this month. In fact, I wrenched the inside of the cell completely out to clean, to ensure there was no contamination. We're running at 1,800,000 hertz, 1,800 kilohertz, and 1.8 megahertz. When you tune your circuit, do not put a lead in parallel with that coil. Tune it till the lights get bright. There's about 50 wraps on that ferrite core. That's about 6 foot of wire. There's anywhere from 6, 8 to 10. My wild guess is about 6 strands is what I used. I said I would share some formulas with you guys. I suggest you write these down. The little man with the head on top, he's got his arms out. That's your free energy symbol. Your inductive reactance, XL, is in ohms. 2 pi is simply 2 times pi. Frequency is always in hertz. L is always in henries. So that is XL, meaning inductive reactance, is equal to 2 pi times frequency times inductance will equal XL, your ohm, or your inductive reactance. You can check your formula. The frequency is equal to XL divided by 2 pi times L. You can check your inductance. Your inductance is equal to XL divided by 2 pi times frequency. Again, frequency is in hertz, inductance is in henries, and XL, your inductive reactance, is in ohms. Now that you know how to calculate your ohms, this is your capacitive reactance formula, just to the left of the right of the inductance. You can see in the top left, XC is your capacitive reactance. To get XC, you need to know your frequency and your capacitance. So it will be 1 over 2 pi, which is 6.28, times frequency in hertz, times capacitance in farads. Always convert to farads when you use this formula. You don't do it in nanofarads or microfarads or picofarads. It will not work. However, you can convert it in the end if you choose to do it that way with another formula. The second formula is your frequency. 1 divided by 2 pi times capacitance in farads times XC in ohms, where the XC you have already calculated over here. So you know XC. XC is your capacitive reactance. Your capacitance on the bottom formula is 1 divided by 2 pi, which is 6.28, times your frequency in hertz, times your capacitive reactance you got from those formulas over there. That will equal your capacitance. When you get your capacitance, it is in farads. You have to convert your capacitance into microfarads or nanofarads. You simply, to convert the capacitance into microfarads, you simply multiply that by the positive exponent 6, or if you want to use nanofarads, you multiply it by the positive exponent 9. And if you want to convert nanofarads back into farads, you multiply that by the nanofarads using the negative exponent 9, and it will equal your farads. So I suggest that you copy this down on a piece of paper, freeze this frame, write those formulas down, write these formulas down, familiarize yourself with them. This is my sheet that I started out with. If you can look at that, you may want to write that down if you're having trouble. Go through and kind of see what I did there. This formula here, this is for your tank circuit. It's useless, but you can use it if you want. The frequency is equal to 1 divided by 2 pi. HF is Henry's, F is frequency. It's Henry's times frequency squared times 2 pi divided by 1. That's what these numbers are over here. You can work your way through it. You can see how I squared it, and you can see how I got my answer. This paper here, you need one of these. This is the most important paper that you will probably use. This is your farads, picofarads, and microfarads. And I have a few frequencies formulas at the bottom to help me out a little bit. This is your resistor color code calculator. It's handy to have one of them. It's no fun digging around when you don't know what you're doing. This will help familiarize you with your Henrys. You will only need 10 to the negative exponent 3. We're not going to be dealing with micro Henrys, nano Henrys, or pico Henrys. That formula is basically one of those that I've already showed you. This is a good chart to have. It keeps you from getting confused. It's a prefix symbol meaning. It's the prefix used with SI units. There's different units. Those are SI units. The frequency at the top, wrote in ink. For those of you that's wanting to use a 555 timer, the frequency is in hertz. 1.44 is a fixed formula in the data sheet you use with that data chip. It is resistor 1 plus 2 times resistor 2 times C1 times 10 to the negative exponent 9. You divide that by 144 and you get your frequency in hertz. That's very handy if you're trying to hit a specific frequency using that timer. If you you don't know how to use an oscilloscope, it's very simple. Your time division setting. It's easy to do in milliseconds, but if you happen to have to set your setting on your microseconds, then you take microseconds and you multiply that by 10 to the negative exponent 3, and it will give you the millisecond format. So now you have a way to convert your microseconds into your milliseconds, which is what you have to do the formulas, is milliseconds. And you also got your seconds. And I didn't write that down because that's pretty simple. So when you know what format you're using, where you switched that, you got your voltage set to where you can see your wave and you count your pattern. If you go across, if you start at the left here and it goes up, comes down here, goes down, and it comes up and it meets right in that X, well, that's 1, 2, 3, 4, 5 divisions. So it will be your whatever your millisecond setting is over here times your division, which is 5, and you divide 10 to the positive exponent 3 into that, and your answer will come out in hertz. It's that simple. That is your 0-point energy. It is deflecting the voltage. I also have a few more things that you need to know. This is your total resistance equals your voltage divided by your current. Meaning total resistance equals voltage divided by current. If you take your voltage and you divide that by your current, that gives you your resistance. Resistor 1 is equal to the voltage drop divided by current. Current times resistance equals voltage drop. If you're dealing with two resistors, R2 is equal to total resistance minus R1. Fairly simple enough. Write that down on a piece of paper. You'll eventually understand it. This is your series capacitance formula. Your total capacitance in series, when you have capacitors in series, it will be C1, capacitor 1, plus capacitor 2, plus capacitor 3, and so on. Then you divide that by 1, and that equals your total capacitance. Your parallel resistance is the same way as your series capacitance. That's what they have in common. Terminology. Look up the definition of that word, terminology. That's in relationship to a pyramid. That's in relationship to Ohm's law. That's in relationship to everything we're doing. Terminology. Look it up. When you can't speak to someone properly and you cannot communicate with them, mathematical formulas are different, things are different here than it is there. Look up terminology. That will give you an explanation. The water molecule has 62% hydrogen atoms in it, 31% oxygen, and 17% nitrogen. Voltage deflection process uses progressive step functions to polarize molecules. Voltage deflection. Look up voltage deflection. Voltage stimulation causes polarization on anything containing an electron or proton. This stuff is good to understand. So now you guys have a lot of what I have. And so you have a lot to go on. And that, my friend, is running on nothing. I don't have a booster circuit. I don't have anything like that. It's ripping these water molecules apart. Isn't it amazing? It's took me since 2006 to get as far as I've got. Now, you guys at ionizationx.com have everything that I have. All with a simple Biffler coil, wrapped 50 times. It's crazy. In my previous videos, there's a tie strap packed on the right of that cell, almost halfway around it, if you're wondering why no bubbles or no molecules was coming out of that. So what you're seeing here is hydrogen molecules and oxygen molecules and nitrogen molecules coming up. So good luck, guys. Carry on. Don't give up.